All right, so we're going to talk about some applications of absolute value. But before we do that, I just kind of want to talk about some absolute value stuff to make sure we all got the same ideas going in our head. So, with absolute value, absolute value, right? So once again, most people just think about absolute value makes things positive, right? And although that is true, I wouldn't recommend thinking about it so much like that unless you know the underlying reasons, all right? So let's talk about, I'm going to say the absolute value of x is equal to 3, right? Or better yet, I'll say the absolute value of x minus, 5 is equal to 3. And what does this mean, right? This means that the distance, right? Absolute value really represents the distance between two things. The distance between x and 5 is 3, right? So if you think about a number line and we start with 5, and we're trying to figure out what x is, right? We want to solve this, which means find x. So the distance between x and 5 is 3. So from 5, I know I need to go up 1, 2, 3, and that is a distance of 3, right? And if I do that, I'm at 8. So that tells me x equals 8, right? X equals 8 is one solution. Well, what if I went the other way? 1, 2, 3. This is also a distance of 3, right? So if I did that, I'd be at 2, right? So x is also equal to 2. All right, that's the idea of absolute values, right? So let's talk about when we get into an equation or an inequality. What if I had, I'll change it up a little so it's not exactly the same. What if I had x plus, or let me change it up a little bit more. I say 2 plus x is equal to, the absolute value of 2 plus x is not equal, no, inequality. I want to say greater than, 4. Well, it doesn't matter if I'm talking about adding or subtracting. I'm still talking about the distance between two things. So the distance between, and you can say 2 and x, because distance is positive. So if I say, well, what's the distance between 2 and x? It's going to be the same as the distance between x and 2 because distance is positive. So the distance between 2 and x, and this, right, this says is more than, right? That's greater than, it means it's more than 4. So on a number line is your friend here. 2, right? The distance between 2 and x is more than 4. So if I go up 1, 2, 3, 4, then I'm at 6. And if I go down 1, 2, 3, 4, then I'm at -2. Right? Well, is my answer, okay, x equals 6 or x equals -2? No, because it says it's more than that. So it means it's everything above that, right? Or everything below that. Can it be equal to 4? Is my distance exactly 4? No. This is, this is that distance of 4, right? Distance of 4. Now, it says it's more than the distance of 4. So it has to be bigger, which means that now my solutions, they can't be equal. They have to be, either bigger or further away, I should say, since we're talking about distance, right? That means I can say my answers would be -infinity all the way to -2, but with a parentheses, because they can't equal -2. Same thing here. from 6 to infinity, right? You might also see that written as x is less than -2 or x is greater than 6, right? So that's absolute value inequalities and absolute value equations. But what about when we're talking about absolute value word problems? So let me erase this stuff real quick. All right, so I feel like, we're gonna. So now first it's talking about either A or B, right? Or I'm sorry, either the absolute value of A minus B or the absolute value of B minus A. Since it's a distance, like I was saying a minute ago, that it doesn't matter how it's written. All right, now let's look at this. It says K is no less than 5 units from 8. Right, so what does that mean? Well, that means the distance between K and 8 is no less than, all right? So what is that? If it's no less than, then it has to be more than, right? Can it be equal to? Or if you owe me no less than $5, can you pay me $5? Yeah. Can you pay me $6? Yeah. Can you pay me $25? Sure. Can you pay me $4? No, sir. You owe me no less than $5. So it has to be greater than or equal. And we're talking about to 5. All right. So K is no less than 5 units from 8, right? From 8, the distance between K and 8 is more than or equal to 5. So K minus 8 is greater than or equal to 5. Absolute value of K minus 8, or you could say absolute value of 8 minus K is greater than or equal to 5. Some people say, well, what about if this was positive, right? Is that the same thing? Well, I don't know what K is. So if it's negative or positive, I can't say. So if you made it positive, we can't make the 8 negative. I mean, I guess you could write it like that. Don't overthink it. Don't overcomplicate this. We're talking about the distance. When you put things in the absolute value, it's talking about the distance between those two things. All right. So write an absolute value. So we've written that one. That's the inequality, or this one, depending on how you want to do it. All right. N is within 1/1000th of a unit of 6. So we're talking about N within 0.001 of a unit in 6, right? So N in 6, that's the number. So look, the distance between N and 6, now it's within, all right? We're talking about a distance. It is within. That means that it is less than or equal to. It's within 1/1000th of a unit. If someone said, how far to the store? It's within 2 miles from here. Can it be 2 miles from here? Sure. Can it be 3 miles from here? No. Can it be a mile from here? Sure. So I'm going to say it is less than or equal to. And we're talking about 0.001. All right, so now we're talking about absolute value of, N minus 6 is less than or equal to 0.001. And that's how you would do this. You could also do it the absolute value of 6 minus N, right? All right, so let's use this. In quality control situations, such as filling bottles on an assembly line, we often wish to keep the difference between two quantities within some predetermined amount called tolerance, right? Suppose y is equal to 2x plus 1, and we want to be within 1/100th of a unit of 4. For what values of x will this be true? All right. So suppose y, right? I'm not going to get into, suppose y, we have this, and we want to be within 1/100th of a unit of 4. So I'm thinking about the distance between y and 4 has to be, if it's within, it has to be less than, right? If you think about, two things, let's not get too crazy. Within, right? In between two things, right? Which also allows within 1/100th of a unit, so it can be 1/100th of a unit, but it can't be more than that. It has to be between right? Like between 0 and 1/100th. So it has to be less than 1/100th or equal to. So I'm going to say the absolute value of y minus 4, right, is less than or equal to 0.01. 0.01. Now, I don't want y, right? I'm trying to solve for x. But y helps me to, keep things simple to begin with. And I know y is equal to 2x plus 1. So 2x plus 1, right, minus 4, absolute value of that has to be less than or equal to 0.01. Now, you can go to the number line with it, but most people kind of learn out absolute value how to deal with it, like what I'm about to show you. So when I find on the more complicated versions, it's just easier to do it with the algebra, but you want to have your underlying understanding there. So we'll simplify this a little further. 2x, now I don't need the parentheses, so I got plus 1 and minus 4. That's minus 3. Right, absolute value of 2x minus 3 is less than or equal to 0.01. Now, I can flip this, right? I want to get rid of the absolute value bars. Anytime you want to make them go away, you got to consider the positive direction or the direction moving right, and then also the direction moving left, because as we talked about earlier, you could go either way, right? So I have 2x minus 3 is less than or equal to 0.01, and I always kind of call this, the positive, which is usually I'm saying the right. So moving right, that's this equation. But then you could also have 2x minus 3 is, now, like in a tolerance, that means something can be heavier. Like since we're talking about olive oil, it can be heavier than the targeted weight by 1/100th or less than that, right? Or it could be lighter, but it can't be any more. It has to be within that. So this, I'm going to say negative 0.01, right? And here it has to be greater than, notice, or equal to. So the sign, the inequality, flips. And the sign changes. Sign change, right? And this is because of, this is the negative version, which is, the left, if you're talking about, going left on the number line, as opposed to going right on it. Now you just solve these the same way. I would say plus 3, same thing over here, plus 3, and I get 2x is less than or equal to 3.01, and then I get 2x is greater than or equal to, now this one would be 2.99. Now I'm solving for x, right? So I divide by 2, and I got x is less than or equal to, so like 1.501, I don't know, 05? 1.505. 5005. Let me get my calculator out for that. 3.01 divided by 2. 505. And then over here, divided by 2. I'm going straight to the calculator on this one. 2.99 divided by 2. 1.495. All right, so that can be our weight. When we think about this olive oil, you know, it can be between these two numbers. The smaller number, 1.495 to 1.505. And since we're talking about a tolerance, right, it's going to be less. You know, I see that it has to be greater than this one, right, or equal to. I'll put these brackets. When something can be equal to, you use brackets. When something is not going to be able to be equal to, use parentheses. I'll talk about that real quick. But here, we're talking about brackets because these, I'm saying this one can equal, right? I'm saying this one can equal. And then we're in between those. X is greater than, 1.495, and X is less than or equal to, for both of them, 1.505. So once again, if I have parentheses, right, then, and I say like, I'm just going to use random numbers to make my point here, but I'll say like 2 and then 7, X cannot equal 2. X cannot equal 7, right? That's what it means. Now let's say you have 2 and then 7 like this. So X cannot equal 2. X can equal 7. Sure, it can equal 7. It can be, it can be equal to 7 or it can be less than 7 in this situation. So not just equal to 7, but also less than 7. And then, that, like this, 2 to 7. Same kind of thing. X greater than or equal to 2. X less than or equal to 7. And then, of course, if we're talking about infinity, infinity to infinity, negative infinity to positive infinity, it's always parentheses. Parentheses. All right, parentheses, because we can't get to infinity, right? That's why Buzz Lightyear was so famous, right? To infinity and beyond. There is no beyond. It's just infinity. You can't get beyond infinity, right? You can't get to infinity because it's always going, right? It's not an actual number. Let's see if we got anything else. Come on now, go. All right, I can see that there's an example. Let's see. Temperature, surface on Mars. What is the range of the temperature? So this one's just asking you to solve it, right? You can solve it and figure out that. And then it says the industrial process that's used to convert methanol to gasoline is carried out at temperatures on this range. All right, let's do this one. Write an absolute value. So, so we got 680 degrees to 780 degrees. Now, well, we always, we're always going some distance from the center of it, right? So that's kind of, you need that center point. All right, when you're doing this, because if you notice on all the ones we've done, if we're if you were in class and when you look on the number line, right, we're moving, it's always from the center outward, right, because that tolerance is within some amount. So, if hopefully you've done them in class with us. If this is the first time you're watching the video, then I don't know that you understand what I'm talking about. But it's always a center point, the reference, right? We need to figure out that reference point that's in the center. So, anytime you want the center of two things, you just add the two things together and divide by 2. So 780 plus 680 divided by 2 gives us 730. 730 degrees is in the center. And now we know we're going to be moving. Well, what is my distance to move from, well, that's a distance of 50, right? Because we're moving in both directions the same amount. And this is, we're going to the right. In this one, we're going to the right. And this one, we're going left, to the left, a distance of 50. Right? So now, hopefully that puts things in perspective for you. And we know that my temperature ranges have to be in between these. And it says range, it has to be carried out in the range of, 680. Can it equal that? Yeah, it can equal that. All the way to 780, and it can equal that too. So it can't be beyond that. It has to be less than that 50. Right? Can't be more than that distance of 50 away from it. Has to be less than that 50. So here we go. Now we're saying the distance between what? Well, F is my variable, so I'm going to say F and my center point, right, 730 degrees, has to be less than, right, or I'm not going to, because I'm also doing it equal to. So it can be equal to or it can be less than. So less than or equal to, and we're talking about that distance there, which is 50. And since this is in degrees, now we can, the absolute value of F minus 730 degrees has to be less than or equal to 50 degrees. And that would be your absolute value inequality. Hope that was helpful for you. All right.